All right, hey everybody, this is going to be the tutorial video for section 11.2 on the surface area of prisms and cylinders. I'm just going to present my screen. Okay, so you should see the handout now. Okay. All right, so our big goals for this section, we're going to start talking about what's called surface area, which really means we're going to be finding the area of all of the outer faces of a 3D figure. So yesterday we talked about three-dimensional figures being called polyhedra. We're going to look at two specific types of polyhedra today and find their surface areas. So we're going to be looking at the surface area of a prism and the surface area of a cylinder. Okay. A cylinder is very similar to a prism, so we start with a prism and then we'll work our way into the cylinder. It just uses circles instead of using polygons. So to start with, what is a prism? A prism is just a polyhedron that has two congruent parallel bases. And what we mean by bases are the two faces of the shape that are parallel that never intersect to each other. So in my picture over here, in this specific prism that I have, I notice that there is a pentagon on top, and there's a pentagon on the bottom. And those two faces will never touch each other. One of them's up in the air, and one of them's down on the ground. They never intersect. Those would be the two bases of my prism. In this one over here, I've got a triangle on top, and I've got a triangle on the bottom. Well, the triangle on the ground and the triangle up in the air are going to always go forever in their own directions and never cross. So those would be my bases. So those that I have in green there are the bases. Oops, let's get cut off the screen. Let's write it up here. Bases. The lateral faces are all of the faces, all of the polygons surrounding the figure that are not bases. So we call them the non-base faces. Kind of rhymes. Okay. So in this one that I have over here, my first one, all of the rectangles surrounding that shape would be my lateral faces because they're not my bases. They actually intersect each other in an edge. So all of those rectangles here are going to be my lateral faces. Same thing in this one over here. All of the rectangles that you see surrounding it that are not bases are my lateral faces. And what we call the height or the altitude, we've seen that word before. Okay. In this case for 3D figures, it's just the distance between the bases. Think of it as a bridge. If I wanted to connect a segment that goes from this end of the bridge in red to this other end of the bridge in red, then this vertical distance here that connects those two bases together would be my altitude. And it will always form a right angle with the bases. And this one over here, here's my one triangle on top. Here's my other triangle on the bottom. This blue segment that I'm drawing in would be my altitude or my height. And in the ones I have here, it's drawn straight up and down. You could have prisms that are tilted where it goes from left to right. The altitude is not always going to go straight up and down. It depends on how the shape is oriented. The way that we name a prism is we name it by the shape of the base. So we name it by the base shape. In the one I have on the left, the base is a pentagon. So we call this a pentagonal. Add an AL onto the word pentagon. Pentagonal prism. This one is a triangle as the base, so this would be what I call a triangular prism. We make it an adjective. So we always name the prism by the shape of the base. Most of the prisms that we're going to deal with are called right prisms, where everything is stacked nice straight up and down, or nice and straight from side to side. So for example, this one and this one would be right prisms. Okay. The height is always going to be one of the edges of the shape itself. That's what I'm highlighting in blue. This height connects these two bases together, and this blue height connects these two trapezoids together. Everything is stacked nice up and down or side to side. Whereas in this one that you see over here, it's tilted. Think of like a CD stack where you slide all the CDs a little bit to the right or the left. Whenever you have one of these tilted prisms, this is what we call an oblique prism. And for the oblique prism, unfortunately, none of the side lengths are perpendicular to the ground, so that height has to be dropped outside the figure. Okay? So that little red segment that I drew right there would actually be my height, as opposed to the first two where the blue segment that I drew was the height and it was one of the sides, one of the edges of the shape. So we want to use these ideas to be able to compute and find the surface area of a 3D prism. And we're going to start by doing that with net diagrams. And by surface area, I mentioned this at the beginning, we're talking about adding up the areas of all the outer surfaces of a 3D figure. We don't care about the inside for surface area, we only care about the outside. So in this net diagram that I have here, this would have been a rectangular prism that got unfolded. I count 6 faces, so there would have been 2 on the top, 2 on the bottom, 2 on the left, 2 on the right. Once I unfold it, what I can actually do is I can find the area of every single face that I have here, and I can just add them all up. That's exactly what I have right here. I'm just going to add up the surfaces of my entire 3D figure. So here's my net diagram. I'm going to fill in a couple pieces of information first. Okay. One thing I know is none of these side lengths right here in red have been labeled, but I do know they have to be at length of 5. I'm just going to write that in. Okay. And using that, now I have enough information to find the area of each rectangle. This top rectangle is a 4 by 3, so base times height would give me 12. This rectangle is 4 by 5, so that's 20. 3 by 5 would be 15. 4 by 5 would be 20, 3 by 5 would be 15, and 4 by 3 on the bottom would be 12. So what I wrote in blue there is just the area of every single face of that net diagram. And to compute the surface area, I'm just going to add them all up. So 12 plus 20 plus 12 plus 15 plus 20 plus 15. If you add all that up, that gives you a surface area of 94 square units. In the second one, they don't provide you with the net, so we're going to be drawing the net diagram ourselves. This would be a triangular prism, and as I mentioned before, it's actually not drawn straight up and down this time. It's drawn from left to right. So the height of that figure is actually not going to be the vertical segment you see here. The height of that prism is actually what I'm drawing in red right here. That's the height of the prism, because it connects the 2 triangles together, the 2 bases. This one right here is your base, one of your bases. So I'm going to draw the net diagram. I'm going to start by focusing on the rectangle on the bottom just to give myself a starting point. So there's one face on the bottom. There's 2 triangles attached to it. Those are my 2 bases. I'm going to draw my 2 triangles. And then I've got 2 more rectangles on the left and right-hand side that are folding up to the top that I need to include. I'm just going to draw one on the right-hand side and one on the left-hand side. And so what I can see from this, my rectangles on the left and right are going to be 12 by 5 rectangles. And my rectangle on the bottom is a 12 by 6. I'm just going to add that into my diagram. This is 6. This is 12. This is 5. And the side lengths of my triangle then also have to be 5. And now what I'm going to do is I'm just going to add up all the areas. So I'm going to start with the rectangles. This rectangle is 12 by 5, so that's going to have an area of 60. This one is 6 by 12, so that's one's going to have an area of 72. This one's 5 by 12, so that one's also going to be 60. So there's my areas so far. I'm just going to keep track of them. For the triangle, I'm just going to draw it separately so we can see it. I can see the edges of the triangle were 5. They gave me that in the original picture. That's 5. That's 5. To get the area of that triangle, remember it's 1/2 base times height. The height in this case being the height of the triangle, not the height of the prism. So I'm actually going to drop that straight down at a right angle. There's my height. The whole bottom is 6. Since it's isosceles, that means it's going to get split in half. So each of these pieces needs to be 3. And then this is one of your Pythagorean triples you should know. This is a 3, 4, 5 right triangle. Okay. So I'm just going to use my shortcut there. You could also just do 3 squared plus x squared equals 5 squared, and you'll get x has to be 4. So that's my height. So the area of one of the triangles, both triangles are the same, is 1/2. The base is 6, and the height is 4 that we just found. 24 divided by 2 is 12. So this triangle has an area of 12, and this triangle also has an area of 12. So then adding them all up now, if I add up all of those surfaces, the surface area is going to be 12 plus 12 plus 60 plus 60 plus 72. It means that entire triangular prism is going to have an area of 216 square centimeters. So we still do square units because we are dealing with area. It's just area of more than one shape. Now, it is kind of a pain to have to draw the net diagram every time. There is a faster way of being able to compute the surface area without having to break the 3D shape apart into a 2D net. And if you take a look on my filled in handout, I kind of run you through how to derive the formula for the surface area of a prism. I'm going to make the video a little bit shorter and skip that explanation right now. If you're interested in seeing the diagram for that and how I came up with that, take a look at my filled in handout. I do have that included with some work. But we're going to be looking at what's called lateral area as opposed to just surface area of a 3D figure. Lateral area of a 3D shape just means no bases. You're only adding up the area of the lateral faces, not including the bases. Whereas surface area in general, if it doesn't say lateral, surface area means include the bases also. So it's the lateral area plus the bases that you have. Whenever we're going to be dealing with a prism, the lateral area of a prism is always going to be equal to the perimeter of the base times the height of the prism. So if you look at the prism that I have drawn here, it's a rectangular prism. The lateral area, if I consider the square on the top and bottom to be the bases, the lateral area is telling you the area of all of the other faces, not including the top and bottom. And so how I compute it is I would find the perimeter of my base, add up all the sides of it, and then I would multiply it by the height of the prism. And that gives me the lateral area. But if I want the entire surface area, the lateral area only gives me 4 of those faces. Now I've got to add on the area of the square on the top and the bottom as well, which is where I see this 2 times b coming from. It means 2 times the area of the base. Anytime you see capital B in this chapter, that's going to be referring to base area. And LA stands for lateral area. Okay. So lateral area is the perimeter of the base times the height. So little p means perimeter of base. And h is the height of the prism. Erase these. Erase, erase, erase. Okay. I'm going to write those one more time here just so we have them for the next couple problems. Lateral area is going to be perimeter of base times height, and the total surface area is going to be the lateral area plus 2 times the area of the base. But those are our two big formulas for now. Let's do the next couple without having to draw the net diagram. Let's use that instead. Make things a little bit quicker. If I look at my first one, this is a triangular prism, because I have triangle on the top and bottom that never intersect each other. Those are my two parallel faces, which we call our bases. Okay. The height of the prism is going to be the distance that connects those two together, that little bridge. So my height in this case of the entire prism would be 6. So just labeling the pieces. In order to find the lateral area, what that means is I want to find the area of all of the rectangles surrounding that prism, but I am not including the triangles on the top and the bottom. So lateral area here, no triangles. The lateral area is going to be the perimeter of the base of the triangle times the height of the prism. Well, in order to know what the perimeter of the triangle is, we need to figure out all 3 side lengths, and we only have 2 of them. But what's really nice is they gave you a right triangle. There's my right angle in the corner. So if I zoom in on that triangle, 3, 4, at this point, your Pythagorean triple should be coming to you. This has to be 5, which means on the bottom, you have an identical copy of that base, which means it also has to be a 3, 4, 5. Those bases are always identical to each other. So now I can easily add up the perimeter. The perimeter of that is just going to be 5 plus 3 plus 4. It's 12. And the height of my prism is 6. Okay, it's not the height of the triangle for this H, it's the height of the prism. So I get 72 square centimeters. That does not include the triangles. If I want to find the entire base area or the entire surface area now of the whole shape, I've got to figure out how much area does that triangle have and that triangle have and add it on. So I'm going to do capital B for the base area. This is my triangle. So I'm just finding the area of one of those triangles. 1/2 the base of the triangle times the height of the triangle from chapter 10. So now I'm just focused on the triangle. Well, I could call this the base of my triangle, and this would be the height, because they intersect at a right angle. Base, height. So 1/2, 3 times 4. 12 divided by 2 is 6. So put it all together, the whole surface area, if I look right here, it's the lateral area plus 2 times the base area. Lateral area we found was 72, and we have 2 of those triangles. Each one had an area of 6 square centimeters. So I've got to add on 2 times 6. 72 plus 12 is 84. So that would be the total surface area, including the triangles. If we do this for another prism here, we have a hexagonal prism is what we would call this, because the base that I see is a hexagon. I'm just going to highlight those in the picture. Hexagon in front, hexagon in back. And the height connecting those 2 hexagons together in this case is not going straight up and down, it's going from front to back. This 12 is my height. Okay. And we're going to assume that's just a regular polygon, a regular hexagon. So the lateral area is going to be adding up all 6 of those rectangles, okay, that are surrounding the shape, but it's not including the hexagon in the front, and it's not including the hexagon in the back, because those are my bases. So the lateral area is the perimeter of the base times the height. If I look at the hexagon, every side length is 6. And these are all congruent. 6 times 6 would be 36. The height is not the height of the hexagon, it's the height of the prism. That's 12. 36 times 12 would be 432 square meters. Okay. So that one's not too long to compute, but now I have to do the base area. Base area is going to take a little bit longer because it's going to give us a little bit of a throwback to chapter 10. In order to compute the base area, I need to focus on the hexagon. I'm going to use the fact that I know the area of a hexagon is going to be 1/2 the apothem times the perimeter. There's the center of my shape. I'm going to draw in my radii like we did last chapter. Drop my apothem. 360 divided by 6 would be 60. Once I split it, this would be 30. This would be 30. This would be 60. This would be 60. Let me just focus on one of those little ones. 30, 60. The whole side length was 6, so we split it in half. Each of these pieces needs to be 3, which means using my 30, 60, 90 rules, this should be 3 rad 3, and this should be 3 times 2 is 6. So there's my apothem. And our perimeter we already computed. The perimeter was 36. So the area, the base area, is 1/2 the apothem, 3 rad 3, times the perimeter, which is going to be 36. So then if you crank that out, there's going to have to be a rad 3 in the answer. 36 times 3 divided by 2 would be 54. So I get 54 rad 3. I'm just going to leave it in exact form for now because the problem didn't specify. So I'm going to show it to you in both ways. We got our lateral area before. We computed one base, but there are 2 hexagons, one in the front and one in the back. So when I do my total surface area, I need to take the lateral area we found and add on 2 times the base area, since there's 2 bases. 432 did not include the hexagons. Each hexagon has 54 rad 3 square meters of area. So you got to make sure you multiply that 54 by 2. 432 plus 108 rad 3 meters squared. That would be if you left it in exact form. Notice I did not add the 432 and the 108 together because they're not like terms. The 108 has a rad 3 multiplied next to it, and the 432 does not have a rad 3 multiplied next to it. If it asked you to round this, sometimes Math Excel has you round, you would just type in 432 plus 108 rad 3 on your calculator, 619.1. So just pay attention to the directions if it says exact form or if it asks you to round. I'm just going to pause real quick, make sure this is still recording. Good. Still going. All right. Number 3, I'm going to make a you try problem. I've done a couple of these so far. I want you to give this a shot. So you can pause this. Okay. But what I do want you to do is make sure it's kind of, whenever you have a rectangular prism, you have options for what you could call the bases. In this case, you could make the top and bottom the bases since they never intersect. But you could also make this square and this square, or I should say rectangle, this rectangle and this rectangle the bases because they also never intersect. So for consistency's sake, because it actually is going to make a difference for your lateral area, which one you use, just so we're all on the same page, let's call the bases in this problem. I'm just going to make a decision. Make the top and bottom your bases. The total surface area will come out to the same answer, but it is going to change the lateral area, depending on which set of bases you use for this rectangular prism. Okay, so pause me, try this one out. Okay, I'll put an answer on the screen for you to check. Okay, but if you want to see the worked out solution, take a look at my filled in copy of the notes, and I have the work computed for you. Okay. Okay, so your lateral area you should have found was 56 square feet. And your total surface area, if you include the blue rectangle on the top and bottom, should have been 136 square feet. If you got those answers, feel free to move on. If you did not get those, take a pause on the video, go to my filled in notes copy, and take a look at the work that I did to compute that. Okay. Any questions after that, feel free to log into the office hour, and I am happy to help you go through that one. Number 4, I think it's important you see an application of this instead of just giving you a shape with no context. One of the most useful applications of surface area is if you're going to paint your house or paint the walls of your house. You kind of have to know how much paint do I need in order to cover that surface. You're going to have to think about things like, well, how much money do I want to spend? Do I want to paint 1 coat on the wall, or do I want to paint 2 coats on the wall? Okay, that would mean you have to multiply everything by 2. These are all questions you have to ask yourself when you're going to do a painting project or a house project. So let's say that you're planning to paint your bedroom walls a new color. You have a 12 by 14 foot bedroom with 9 foot high walls. Okay, so let's do this first. Let's draw a bedroom. I'm going to show you how to draw a 3D figure. We're going to make it a rectangular prism. I'm going to start by drawing a rectangle as best I can. And then what I'm going to do is I'm going to draw another one, and you could either draw it kind of up in the left or up in the right. I'm going to draw it up in the right, and I'm going to make it the same size, and it intersects the one I already drew. And then I'm going to connect the corresponding vertices together. So this top left corner is going to connect to this top left corner. This top right corner is going to connect to this top right corner. This bottom right corner is going to connect to this bottom right corner. And this bottom left corner is going to connect to this bottom left corner. So that's kind of a little lesson in 3D drawing. You'll get better at it over time if you practice it. Okay. Now, what does it say? You're painting the walls of your bedroom. Last time I checked, the ceiling and the floor are not going to get considered to be walls. Okay, especially not the floor. You're not going to paint your floor. Okay, so I'm just going to put an X through those 2 surfaces. We really only care about the lateral surface in this problem. We don't care about the base on the top and the base on the bottom because those are not walls. Okay, so let's keep reading. We know it's a 12 by 14 foot bedroom. So they're giving you the length and the width of the bedroom. 12 feet by 14 feet. And we know that the walls are 9 feet high. So this distance from bottom to top, connecting the bases, is 9 feet. You know that you're going to need 2 coats of paint. That's going to come into play in a little bit. And you can't return it. Okay? So we got to make sure we calculate everything correctly, because otherwise we have more paint than we need. Each gallon covers 400 square feet. How many gallons of paint do you need to buy? In order to figure that out, one thing I noticed is they're talking about square feet. And that makes me think area. So I'm going to have to figure out how much paint do I need to cover the left surface, the right surface, the front surface, the back surface, okay? But not the top and bottom. So what am I concerned with in this problem? I only care about the lateral area. It means no ceiling, no floor. Lateral area of a prism is just going to be the perimeter of the base times the height. Well, my base is 12 by 14, and since it's a rectangle, opposite sides are congruent. So I'm going to get 14 plus 14 is 28, 28 plus 12 is 40, plus 12 is 52. So the perimeter here is 52. And I'm multiplying by the height, okay, the height of the actual prism itself. The height of that prism is 9, because it connects the bases together. 52 times 9, crank that out, be 468. Okay, but here's the key. That's one coat of paint. That would be if you took your paintbrush and did this exactly one time. But in the problem, we got to read it. It says you need 2 coats of paint. Round 1 took you 468 square feet. You go have lunch. Okay. And then all of a sudden you say, oh, wait, it said 2 coats. Now I got to do this one more time, which means you're going to have to double the amount of area that you did. I had 468 for round 1. Multiply it by 2. After I'm done with the whole project, I'm actually going to have 936 square feet of paint. Okay, so that tells me how much paint that I need, but you're not going to go buy a gallon of paint that has 936 square feet. All of the gallons come in sizes of 400 square feet. So you go to the paint store and you tell the person, well, I know I need to have 936 square feet to paint my house. You look, okay, each gallon covers 400 square feet. I'm just going to divide those 2 numbers to see how many gallons I should buy. So if I do 936 divided by 400, $2.34. Now, normally, rounding rules would tell us to round down since the 3.4 is less than 5. But if you only go with 2 gallons, you're going to be cutting yourself short of some of that paint that you need for those 4 walls. So what that tells you is in a problem like this, you have to round up. So you get 3 gallons. 3-gallon cans. And that just means you have some paint left over. So if you ever decide to paint your garage, or just do some other type of painting project, you got a little bit of paint left over. So always good to see an application problem. The last one I have here for prisms is what's called an open top box. And you'll see these from time to time. It's pretty much what it sounds like. It means that you have this 3-dimensional box, but it has no top, so you can see inside. Like when you open up a present, you can see the inside. You took the cover off. Okay. Why that's important in this problem, if I look at this triangular prism, I do have a base on the bottom that's a triangle, but the one on the top is missing. It's just open. There is no surface here. It's open, which means we're not going to be including it in the surface area because it doesn't actually exist. You only have 1 base in this problem. You don't have 2 bases, even though it's a prism. And that's because it's an open top box. So in order to find, what do they want us to find here? Find the surface area of the pieces of cardboard needed to construct this open top box. Okay. Well, my surface area is going to be my lateral area. Normally I'd be using 2 bases, but I don't have a top. So I'm only going to use 1 base in this problem. Not 2B, just 1B. The lateral area is not affected by that. That's just going to be the rectangle surrounding. So I need the perimeter of the base times the height of the prism. They gave me the height. Connecting triangle to triangle is a length of 8. And do they give us the perimeter? Let's see. No, they don't. But they do give us a 60 and a 30-degree angle, which means I know the missing one here needs to be 90. I'm just going to draw my triangle separately. (30°, 60°. Since this piece is 6 on the bottom and this face is a rectangle, this top opposite side also needs to be 6 across from the 30. Using my 30, 60, 90 rules, here's my L, here's my L rad 3, here's my 2L. I would know this has to be 6 rad 3, and this has to be 12. And then perimeter means add them up. So the perimeter of my triangle, my base, in this case, would be 12 plus 6 rad 3. You can't add all 3 together as like terms because this one has a rad 3 and these 2 don't. These 2 can make 18, but then we just have to tag on the 6 rad 3 and leave it like that. So I'm going to really be distributing the height to that perimeter. The height was 8, and the whole perimeter is 18 plus 6 rad 3. So I get, if I distribute, 18 times 8 would be 144. And then if I distribute 8 times 6 rad 3, I would get 48 rad 3. There's my lateral area. Now I need the base area. Well, looking at the triangle, here's my base of the triangle. Here's my height of the triangle. And I know the area of a triangle is just 1/2 the base times the height. So I get 1/2. Here I'm using little b, not capital B, because I'm just talking about the base of the triangle. And h in this case, I'm not using the height of the prism, I'm using the height of the triangle. So I'm not using the 8, I'm using the 6 rad 3. 6 times 6 is 36. 36 divided by 2 is 18. So I get 18 rad 3. So then my surface area, in this case, would just be adding these two together. Surface area is lateral area, 144 plus 48 rad 3, plus my base area was 18 rad 3. Those two are like terms because they both have a rad 3, so I can combine them together. This would be 144 plus 66 rad 3. And did they give us units? They did not give us units, so we can just write units squared. The problem also didn't say whether or not to use exact form or to round, so if you were to type this in and round it, 144 plus 66 rad 3 would be 258.3. That's just a matter of typing it in. And on a quiz or a test or on Math Excel, it would make it very clear to you what specifically it would want, exact form or rounded form. Okay. All right, before I move on to cylinders, let me just make sure this is recording. I always want to check, because the other day my hand hit the recording and it stopped presenting, and I didn't know until the end. Good, we are still good to go. All right, so cylinders, what's nice about these is they're very similar to prisms, except we're dealing with circles as our bases instead of dealing with polygons. But the formulas are pretty much almost the same. Okay. So a cylinder is a solid. It still has two congruent parallel bases. So far, sounds just like a prism, except they are always circles, not polygons. So technically, a cylinder is not a prism, okay? Even though it behaves just like one. So that circle on the top and bottom looks like two little CDs. Those are my bases. And the cylinder could also be drawn from left to right, in which case the bases would be on the left and right instead of on the top and the bottom. Think of a soup can. A soup can is probably the most famous example of a cylinder. Cylinders can either be right, meaning straight up and down. If these were CDs, it'd be like stacking the CDs edge for edge right on top of each other. Or they can be oblique. If you were to take the CD stack, push it a little bit and tilt it to the right or left, well, now this vertical piece can no longer be your height. This horizontal piece can no longer be your height. Now the height is going to have to be dropped outside so that it still forms a right angle with the base. Okay. So we're mainly going to deal with these two. The lateral area of a cylinder, okay, well, you have to think, lateral area, remember, means I don't want the bases. So that would mean I don't want to include the area of the circle on the top there, and I don't want to include the area of the circle on the bottom. So it's really just the rounded part of the soup can. Think of it as like the label of the soup can. How much area was needed to make that label? And the easiest way to find that area is to unfold the cylinder. I'm going to show you something real quick, just so you can get a visual for this. And am I visible? I am. I'm just going to take a sheet of paper. And right now, what I've made is I've made a cylinder. Here's the base of the cylinder. It's a circle. And if you look at that length around, this length is just the circumference of the circle. But once I unfold that, what happens is that circular part that I had is now just the length of that rectangle. If you watch it again, here's the length of my rectangle. Once I fold it up, that folded piece becomes the circumference of the circle created as the base. Unfold, length of rectangle, refold, circumference of circle. Okay. So it makes it easier just to look at it unfolded as a net diagram with the rectangle. I'm going to represent. Where'd we go? Okay, we're back. So the lateral area, if I don't include those circles, I just showed you unfolded, this length just turns into the circumference of the circle. And that's the height of the cylinder is just still going to be the height of the rectangle. I didn't change that. So the lateral area, if I was to just take the area of this rectangle, base times height would be the circumference, or the perimeter of the base, times the height. And that perimeter in this case is just the circumference. And what do we know about circumference? You could think of it as 2 pi r and then times h. Or we also saw in chapter 10 the circumference is just pi times the diameter times h. But in general, it's really just the perimeter of the base times the height. The perimeter just happens to be the circumference in this case. The entire surface area, though, well, now look at the net diagram. This is your 2 pi rh. That's your lateral area, is the rectangle. But now you got a circle on the top and a circle on the bottom. Each of those circles has an area of pi r squared. So each of my b's is pi r squared. Pi r squared plus pi r squared would be 2 pi r squared. So I still get 2 bases. So it's the same formula as you would have for a prism. It's the lateral area, which is that rectangle in this case, this soup can label, plus 2 bases. They just happen to be circles. So you can just use this, or if you like it to be a little bit more specific, you can do lateral area, which was this one, plus each base is pi r squared. There's 2 of them, so plus 2 pi r squared. Okay. So let's take a look at an example. Here I have a cylinder. I can see that I've got my circle on the top and bottom. Those are my bases. So my height in this case would be 8, connecting those 2 circles together. I want to find the lateral area and then the surface area, including the circles. Okay. So remember, surface area means with the bases, with the circles. The lateral area is just the perimeter of the base times the height. Okay, remember, the perimeter is going to be the circumference in this case because it's a circle. Use C for circumference. And they gave me a radius in this case. The distance from the center of that circle to the edge is 2. There's my radius. So I'm going to use 2 pi r and multiply it by the height of my cylinder. 2 pi times my radius is 2 times my height in this case is 8. And I'm going to leave my answer in terms of pi. 8 times 2 is 16. 16 times 2 is 32. And then just remember to tag your pi onto the end of that. So 32 pi centimeters squared. In order to find the total surface area, I'm going to need that base area. The base is a circle, with a radius of 2. So I'm just going to get pi r squared. Pi times 2 squared would be 4 pi. But the total surface area uses the lateral area plus the 2 bases, top and bottom in this case. So the lateral area we found was 32 pi plus 2 times each base area we just found was 4 pi for each circle. So 32 pi plus 2 times 4 is just 8. And then I tag the pi onto that. Since both of these have a pi, I can add them together as if they were like terms. So my surface area here would be 40 pi centimeters squared. And if the directions asked you to round that to the nearest tenth or the nearest hundredth, you would multiply 40 times pi into your calculator. But I'm just going to leave these in exact form. Switching over. Find the lateral area and the surface area for the label for this can of cocoa. Hot cocoa would be a good thing to have here at home right now. Remember, lateral area is not going to include the circle on the top and bottom. So I'm going to draw the extra circle on the bottom that we don't really see. This time they give me a diameter all the way across. So this diameter is 7. So if I want to find the lateral area, it means no circles, just that surrounding soup can label, the rounded part. So that's going to be perimeter of the base times the height. Height in this case, connecting the circles together, is 5. Perimeter, circumference, they gave me a diameter in this one, so I'm going to use pi times diameter for my circumference formula instead of 2 pi r times h. I get pi times 7 times 5. So I get 35 pi inches squared. There's my lateral area. In order to get the surface area, I need to find the area of one of those circles. Circle has a radius of 7 divided by 2 is 3.5. So pi r squared, pi times 3.5 squared would be 3.5 squared is 12.25, and then I'm going to tag a pi onto it. So my total surface area would be lateral area, and I have 2 circles, so 2b, or not 2b. Okay, that was a bad joke. 35 pi plus 2 times the base area we just found for the circle was 12.25 pi. So I get 35 pi, 2 times 12.25 is 24.5. Remember to carry down that pi. Hooray for like terms. I can add these together. So 24.5 plus 35 would be 54.5 pi inches squared. The lateral area without the circles is 35 pi. Surface area including the circles is 54.5 pi. The last one is what I call a funky shape problem. This is more of a challenge problem, because what it really has is it has a rectangular prism in the middle, and on each side surrounding it, you actually have half of a cylinder. Okay? So you have half a cylinder on the left side here, and you have half a cylinder on the right side over here. Squeezed between them is this rectangular box. So I can outline that for you. There's your box, and then in blue, there's your half cylinder. There's your half cylinder. So think about it. If you were to put those 2 blue pieces together, you would get 1 full cylinder. So what are the shapes we're dealing with here? We really end up with a full cylinder, plus we end up with a rectangular prism. And they're just fused together. It looks like an ice rink. But if we're going to find the surface area, now they didn't say lateral, they just said surface area, means total surface area. All the faces added up. Remember, surface area means outside of the shape. I spy a couple surfaces in this problem that are on the inside. This red face right here and this red face right here are inside the shape. Okay, so that's not going to be included as part of my surface area. So what do I need to find? Let's start with the cylinder. The cylinder's faces are all included. I'm just going to pretend like I took the left cylinder, half cylinder, and the right half cylinder and fused them together to just make one shape. Okay. So the two half cylinders make a full cylinder. What do I need? Well, if I want to find the lateral area, I need to know the perimeter of the base, so I need the circumference. They told me in this problem, what do we know? Oh, this little diameter right here is 4, right across the top. So I know the diameter is 4. And from top to bottom, connecting those two half circles together, that height in this case they're telling me is 3. So I know the height from top to bottom is 3. So the lateral area of that cylinder is going to be the perimeter of the base times the height. So circumference would be pi times diameter, so 4 pi times the height is 3, so 12 pi. And then the base area, if I look at one of the circles on the bottom, if the diameter is 4, that means the radius has to be 2, cut it in half. Pi times r squared would be 4 pi. So then the total surface area for the cylindrical parts of that big object are going to be the lateral area plus 2 times the base area. Lateral was 12 pi plus 2 times the base area is 4 pi. So this would be 12 pi plus 8 pi be 20 pi meters squared. So that takes care of the blue pieces of this shape, but how about the red box on the inside? I need to know the top surface, the bottom surface, the front surface, and the back surface. I don't care about the left surface and the right surface because they're covered up. They're not on the outside of the shape. So I'm only going to look at, next thing I'm going to do is look at the red box. Let's look at the dimensions of the box. The height of the box, they told me, was 3. On the bottom here, it's 6. And since this piece was 4, that means this piece also has to be 4. And again, I'm not using this surface on the left, and I'm not using this surface on the right. The front and back are going to match, and the top and bottom are going to match. So if I look at the front face and the back face, those are just 6 by 3. So base times height would be 6 times 3 would be 18. And then since there's 2 faces, I have to multiply by 2. It'd be 36. And then I've also got the top and the bottom I have to worry about. I'm almost treating this like a net diagram where I'm just adding up the faces areas individually instead of using the lateral area formula. So the top and bottom, this guy and this guy, those are 6 by 4. 6 times 4 would be 24, but that's just one face. You have 2 copies of it. 24 times 2 would be 48. And then I got to add all those together since I'm doing surface area. 36 plus 48 would be, oh my goodness, 84. So what do I have to add together now? My total surface area. If I include all of these circles, the lateral area on the outside, this curvy part, and I include the pieces of the box that I want, not including the left and right, my total surface area is going to be the 20 pi square meters plus the 84 square meters. So my total surface area, call this step 3, for the shape is going to be 20 pi plus 84. And that would be leaving it an exact form. I can't add these together because this has a pi, this does not have a pi. That would be my exact form. If the problem asked me to round it, I would type into my calculator 20 times pi, hit enter, and then add 84. So 146.8. Okay, so those funky shapes take a little bit more work. We're going to be throwing in plenty of those as we go, so you'll get some more practice looking at shapes that are combined together. Okay. All right, the Math Excel will be posted. I have a filled-in copy to this handout on my website and within your Google Doc as well. Feel free to have a look at that. Log into office hours, say hi, ask some questions. Happy mathing.